Hi everybody, welcome to another video in Trigonometry, section 7.1, Law of Sine. This chapter is probably the easiest chapter of the whole book. Very straightforward. We deal with very concrete formulas, Law of Sine, Law of Cosine, and then the last section, area of triangle. So we have formulas. Just need to know when we use what formulas, and then of course we just do a lot of practice. That should be enough. Right. So law of sine. Solving oblique triangles. Oblique triangle here means it is not a right triangle. It is not a right triangle. So it is not right triangle. That means there's no 90 degrees angle in any of the angle. Yeah. So no angle equal to 90 degrees. That's what an oblique triangle means. Yeah, that's what I said. Right. Of course, solving a triangle meaning we find all the missing information about a triangle. So a triangle has three sides and three angles, and we have to know three information to find the missing other three information. So once again, a triangle has six information, three angles, three sides. We have to know three in order to find the other three, and we cannot know three angles, because if we have three angles, we might have a bigger triangle that is similar to it still. So we need three information to find the other three information, and one of those information has to be a side. We cannot have all angles. Right. So these are the case where we have a unique solution: angle, side, angle, 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 side, side, angle, side, and side, side, side. So what does all this acronym means? So I mean all the abbreviation means angle, side, angle, meaning that we know an angle and we know a side in between, and then we know the other angle. If we know this information, that is angle, side, angle. Next, angle, angle, side, meaning we know an angle here and an angle here and then a side. So that is angle, angle, side. Next, side, angle, side. We have a side, an angle in between, and then the side here. Of course, the last one is easy: side, 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 meaning that we know all the three sides. I mark differently so they will not be the same. Right? So these are the scenarios we have a unique information. Right. The next one is side, side, angle. This may not determine a unique triangle. Right. And it's an overview where we have two angles, when we are given two angles. These two scenarios, we use the law of sine. So we use law of sine when we know two angles. Actually, there will be a little more precise statement than that, but in general, we use law of sine for those, and then we use the law of cosine for these two. Law of cosine in section 7.3. And this case, we spend the whole section 7.2 talk about this special case, side, side, angle. Don't spell backward though. Right, in this case, that is in section 7.2, and we also use the law of sine. Right. So I didn't draw the case, but meaning that if we have a triangle, we have a sine, another sine, but then the angle is not in between the two sides. This is the sine angle situation, and this may not have a unique solution. Right. So once again, we given three information, and we asked to find the other three information, and one of them has to be sine, and in that case, this is our only scenario we have. Unless it is the sine angle, they should have a unique solution. Right. Now, after that, what is the law of sine? So law of sine saying, by the way, we have this convention of naming the triangle using the capital letter for angle and little letter, lowercase letter for size. Opposite to angle A is the sine A. Opposite to angle C is the sine C. Opposite to angle B is the sine B. Law of sine is straightforward. Sine of A over A equals sine of B over B equals sine of C over C. And of course, we can just also flip them backward. A over sine A equals B over sine B equals C over sine C. Of course, when I said A over sine A, I mean the sine little a divided by sine of angle A. Of course, it would make sense if we talk about the size of a sine values, right? So sine of an angle, and when I say ABC by itself, that means it is a sine. Right. And we use the law of sine when a pair of opposite sine angle are known. Right. Before we know that, of course, they actually equal to a quantity too. So imagine if we have a circle that goes through all of these points. Yeah, so let's say if we have a circle, if there is a circle go through all 3 points, and there's the center and the radius, law of sine says this is equal to 2 times that radius, the radius of the circle that go through all 3 points. Yeah. So actually, there is a quantity that it is equal to. But this is just trigonometry, so all we need to know is the law of sine. Sine of an angle over the length of the opposite side will be equal to constant for all 3 pairs of angle and sine. And most importantly, we know, because we know the law of sine, and we know when to use it. That's straightforward. Use law of sine when we have a pair of opposite sine angle unknown. This is where we use the law of sine. Now go back to our scenarios. Here we don't have the sine to opposite angle and sine. However, if we know 2 angles, they add up to 180 degrees, suddenly we will know the third angle as well, right? Subtract from 180, we know the third angle. Having said that, now we have opposite sine and angle, that law of sine. Opposite sine and angle, law of sine. The other, we don't have it. So law of sine is used when we know a pair of opposite sine and angle. Simple enough. Right. And finally, before we actually go to solve any triangle, we'll just look at the important facts about triangles. Okay, we will use this whenever possible. The sum of the measure of all three angles in any triangle is 180. So if the triangle is ABC, we can just simply say A plus B plus C is 180 degrees. Next, any side is shorter than the sum of the other two sides. This in the next section we will see that. That's actually very trivial. If we have one side that is way too long compared to the other two sides, there's no way these two sides will touch and form a triangle, right? So the two sides have to be add together. Two sides add together have to be longer than the third side to form a triangle, right? So that's an important fact. And the last one is also important. Bigger angle faces longer side. So in that case, we can check the answer if it makes sense. Right, so sum of the angles add up to 180. Bigger angle face longer side, and because the triangle inequality, one side cannot be longer than the other two put together. Or I should say, one side is shorter than the other two sides put together. Right. Now, like I said, this section is very straightforward. When to use the law of sine and what is the law of sine. So, what to use, what is the law of sine and how to use the law of sine, and then we just need a lot of practice. That will be good enough. And I only need to do like 2-3 examples. Right. Now, let's look at a problem. Showing triangle ABC with angle A is 62 degrees, C is 14 feet, and angle B is 74 degrees. Right. So even though we are not given the triangle, at least we always try to draw it. It's just a generic triangle, doesn't have to be precise measurement. Okay, I just have a triangle like this. See angle A, B, C. Opposite to that is A, B, and C. So, and also just write down what we have and what we don't have, so we know what to solve for. So we draw the summary like this, and I recommend you to do the summary, so we know what we looking for and what do we need to solve for. And what we are given. So we are given angle A 62 degrees. Just right. Here's A 62 degrees. So here will be A, B, C. Right, what else? C is equal to 14 feet. C 14 feet. And then angle B is 74 degrees. So what we are given, those, right? So here we write angle A, angle B, angle C, sine A, sine B, sine C. Right, now we just need to find the missing information of this triangle. So first, in any triangle, the sum of the angles add up to 180. So we use that whenever possible. Usually when we are given two angles, we can find right away what is the third angle. So first, A plus B plus C equal to 180 degrees. We know A, we know B, then certainly we know C. So we have C equal to 180 minus b minus c minus b minus a, sorry. So we have 180 minus b of 74 degrees and minus a 62 degrees. So 180 minus 74 minus 62, that gives us 44 degrees. And this is little size, that is the big angle C. So if you write C by itself like this, it is confusing. So let's just write a little loop like that. That means the angle C equal to 44 degrees. Yeah, so we found C of 44 degrees. Right, so that's the first part. Now, of course, the easiest, we are given two angles. We know the third one. Subtract from 180. Next, what we have here, a pair of opposite sine angle. From here, we use the law of sine. I mean, knowing the pair of opposite sine angle, this is the law of sine. Use orange. So we know the opposite sine angle. This is law of sine. Of course, I can write out what is the law of sine. The sine of an angle over the opposite sine is the constant. So we have three pairs like that. So rather than remember what is A, the formula actually have A, B, C, but just need to know the idea of the law of sine is that sine of an angle over the opposite sine, which we don't know, so just write A. Sine of an angle over the opposite sine, which we don't know, so we just write B. Sine of an angle over the sine of the opposite. This time we know, right? So rather than write out what is A, what is B, what is C, sine A over A, sine B over C, it doesn't mean anything. It is better just know that the law of sine is sine of an angle over the opposite sine. So in this case, we do not know A and we do not know B, but we can find them, right? So sine of angle A over little a, sine of angle B over little b, and sine of angle C over little c. That. Now, the rest is easy. We have this ratio. Certainly, we're going to use this ratio because we know both angle and sine. That's where we use the law of sine, right? So we know one of the ratio. Now, let's look at this. If we just group this together, we can solve for sine B, right? So now if I put this together and cross multiply, B sine of 44 degrees equal to 14 sine of 74 degrees. And then solve for it, we have B equal to 14 sine of 74 degrees over sine of 44. By the way, this is a triangle. We use angle, so let me use angle in degrees. Make sure it's in degree mode before we do this chapter. It's very important. It has to be in degree mode. Right, degree, yep. Right, now we have 14 sine of 74 degrees divided by sine of 44 degrees, and we have 19.37. Yep, pay attention closely in the homework. How many decimal places do they want? In this case, I just write one decimal place. 19.4 for B. The unit will be the same as this. Feet. Now we know B. Of course, we can use that ratio to find A. However, since B is the rounding number, this B is the rounding number, I try not to use it. So instead, I will use the first ratio and the last ratio. I can find angle A. Even though the 44 degrees is also the number we calculate, but there's no decimal places, so we assume that it is more accurate than using the rounding numbers here. Right. So using the ratio of the first one and the last one, again cross multiply A sine of 44 degrees equal to 14 sine of 62 degrees. So in that case, A equal to 14 sine of 62 degrees over sine of 44 degrees. Right? So I can just change this to 62 and that's it, but 14 sine of 62 degrees divided by sine of 44 degrees, 17.79. So let's say 17.8. So that is equal to 17.8 feet. So now we solve for the triangle. Alright. So pretty straightforward. The last thing we do need to check is that, of course, all the angles add up to 180 because we subtract from 180. So that's certainly check. And one thing we need to check is that the bigger angle will face the longer side. The biggest angle here face the longest side. The smallest angle face the shortest side, and then the other angle, right? So make sure we check that. So very straightforward. Write out this summary. If we know two angles, we know the last one too. If we have a pair of opposite sine angles, that is the law of sine. And then when we do that, make sure we check the answer. Bigger angle face the longer side. Right. That is, in this case, by the way, angle, sine, angle situation. That's where we use the law of sine. Right, next. Solve the triangle ABC with A is 46 degrees, B is 100 degrees, and little a is 10 meters. Right. Once again, I will draw a generic triangle to get a better picture of what we are dealing with. I said it doesn't have to be the right measurement. So we just put the numbers there so we know easier to visualize. However, here we said B is 100, so yeah, this makes sense if it is the biggest angle. A is 46 and C we don't know. Little a is 10 meters. Right, so what we know is angle A 46 degrees, angle B 100. The sine A 10 meters. That's what we are given. We do not know sine B, we do not know sine C, and we do not know angle C. Right. Now let's put all of that in the summary of the answer. I always recommend you to do this. Right, so what we are given: angle A 46 degree, angle B 100 degree, angle C we don't know, but that can be determined. Right. What else do we know? Sine A is 10 meter. Do not know B, and we do not know sine C. So of course, when we draw the summary like this, we know exactly what we need to do, right? First, the angle add up to 180, so we can find angle C. Of course, after that, this problem we have the sides of opposite sine and angle, right? Sine and opposite angle, we do know that, so this is definitely a law of sine. But first, since we know two angles, we know the last one. So in this case, angle C equal to angle C equal to 180 minus A minus B. Yeah, of course, no two angles. We know the last one. To C equal to 180 minus 100 minus 46. Be 34 degrees. And we have 34 degrees. Right? Of course, knowing two angles, we know the last one. Next, we know the side opposite angle and sine. So this is the law of sine. So law of sine, sine of an angle over the opposite side is constant. Sine of an angle over the opposite side is constant. We don't know that. We don't know side B, but we do know it is equal to. And sine of 34 degrees over C, which we don't know either. Right? So it's like that. It's better than when we have this information, write the number directly instead of write A, B, C in general. Right? Now, we know this ratio. That's why we use law of sine. And so, if we use these two ratio, cross multiply, we can solve for B. So B times sine of 64 degrees equal to 10 times sine of 100 degrees. And then we can solve for B. So 10 sine of 100 divided by sine of 64, which is 10.95. I said pay attention on the test, on the homework, where they tell how many decimal places they want, but in this case it is 10.9, but it is 11. If we round to 3 decimal places, so 11.0. If we take 3 decimal place, 1 decimal place, right? Unit is meter. Right. Of course, make sure you enter the right information. 46. 46 degrees, right? I don't know why I write 64 here. That's 13.7. Oh, better. Sorry. I did mention that this section is not that difficult. We just need to know what is the law of sine and when do we use it. And after that, just need to be careful. Right. So that's the first. We know that, and finally we just need to find the sine c. So the sine c, we use the ratio that we know, which is the first one, and we don't want to use b. Even though we know it, it is not ideal to use something that we calculate and we round enough. We use these two ratios. Again, cross multiply c of sine 46 degrees equal to 10 sine of 34 degrees. So we have angle C is equal to 10 sine of 34 over sine of 46. So 10 sine of 34 divide sine of 46. It is 7.77, so let's just say 7.8. And this is not, make sure it is the right unit. There's no degrees here. 13.7 meter. Right. So make sure we write the right unit also. All the angles add up to 180 degrees, and they do. And finally, the biggest angle face the longest side, the smallest angle face the shortest side. That check. So yeah, that's what we have. So like I said, simple enough. Just need to be careful. Right, so just that. Right, next an application problem here. So two lookout towers A and B are 5 miles apart, so we know that. A column of smoke is sighted at A with bearing of north 75.2 degree east from tower B, and with bearing of 53.4 degree west of tower B. Okay, so it is like that. So north 75.2 degree east from tower A, and north 53.4 degree west from tower B. So that's what we have. So this the question is, how far is the 5 from B? So meaning that we asked to find this angle here, asked to find BC. So let's just once again write out the information what we have about for this triangle. Just put a summary. So what we know is that, of course, opposite to angle A is sine A, opposite to angle B. Opposite to angle B is sine B, and opposite to angle C is sine C. So in this case, we have C is equal to 5.2, right? Because that's opposite to angle C. So C is equal to 5.2 miles. What else do we have? What angle do we have? Right, not directly though, but in this we have the total angle here is 90 degrees. Subtract 75.2, we actually will have the angle A. So angle A equal to 90 degrees minus 75.2. 90 degrees, the right angle, minus 75.2. And we have 14.8 degree. Similarly, this also 90 degrees. Subtract 53.4. We have angle B. 90 minus 53.4. 36.6. Yeah, so that's what we get. That is angle B. Alright, so we have A, we have B, angle A, angle B, and then sine C. Know three information, should be able to do that. If we know three information and one of them is sine, should be able to find it. It might not be a unique solution, but or maybe no solution, but at least we know where we're going, where we know three information and one of them is a sine. Right, so like what we have earlier, known two sides, known two angles, should be able to find the third. A plus B plus C, 180 degree. So we can solve for C. C is equal to 180 minus the other two angles. So 180 minus this, and then minus that, 128.6. Now, since we have a pair of opposite sine angle, this is a law of sine. And then in this problem, we ask how far is the phi from B. So we just need to find this sine. So just need to find this. Right. So since we now use the law of sine, of course we write out the law of sine. Sine of an angle divided by the opposite sine is a constant. Sine of an angle divided by the opposite sine, and sine of an angle divided by the opposite sine is constant. Obviously we're going to use the last one since that is the pair of opposite sine angle, and we only need to solve for A, don't need to solve for B, because that the question asks. So use the first and the last ratio, cross multiply. A sine of 128.6 degree equal to 5.2 sine of 14.8 degree. Right, so that's simple enough. Then we solve for A. 5.2 sine 14.8 divided by sine of 128.6. It is 1.67. Let's actually take a few more decimal places. Yeah, that's fine. 6, 9, 9, 6, 6 mile. Now this one we want in the nearest foot. So 1 mile is equal to 5280 feet. So in this case, that is mile. So in the last, we just need to do the conversion. 1.69966 mile. The ratio is 5280 feet is equal to 1 mile. So the mile and the mile cancel. So we just take this, multiply by 5280, and we have that much, 8,974 feet. This is one to the nearest foot, so that's what we have here. Of course, the biggest angle face along this side, we haven't find this out yet, but that is bigger. This angle is bigger that angle. This side should be longer that side. Not by the ratio. We don't know the particular ratio yet. Of course, the ratio have to have the sine in it, but it's just this angle is bigger that angle. The sine will be bigger that side. That's what we have. Right. So just needs a lot of practice, but very simple idea in this section. What is the law of sine and when do we use it? When we have the answer, make sure we check. All the angles add up to 180 degrees, and opposite to bigger angle is the longer side. Right, that's all I want to do in this section. See you in another video in trigonometry. Thank you for watching.